Hello, a very good evening to all. So in this video, we are going to solve our first AIET test video solution, right? So I'm going to explain you all the details and all the how in the problem in which you face some problem. So I'm going to solve each and every question in this class. Basically those questions which are very important for the exam point of view or the question in which you face some problem, right? So this is going to very interesting class for this. This is the first AIT video solution test. So in the further class also we are going to upload as like that, right? So आगे भी हम लोग ऐसे ही upload करेंगे जैसे ही exams होंगे हमारे cover. Just after the exam, we are going to upload the video solution of this chapter, right? So let's start with the today's session. Hmm? चलो. So the first question is that is a zero point 0.5 gram of the fuming H2SO4, that is oleum, right? They are talking about the oleum, not H2SO4, that is SO3. Oleum is diluted with water. Now this solution is completely neutralized by 26.7 ml of 0.4 normality NaOH. Now in this question they are asking calculate the percentage of free SO3 in the sample. So I hope many of you facing a problem in this question, and अगर जिसने solve किया है, that's very good, right? So this question is very interesting and we can say that this question is a very good level, right? So let's see the solution of this question. How will you solve this? So we know that basically one very important note here, that is what is oleum, right? So basically consists of oleum consists of two things, that is SO3 and H2SO4, right? H2SO4. If I'm talking about the formula of oleum now, then it will like H2, S2 and O7, right? So this is the general formula for this oleum. So oleum consists of SO3 and H2SO4. So this point is very important, that is H2SO4 and SO3. Just wait for a second. Right. So oleum consists of a SO3 and H2SO4, that is H2SO7, right? So let us, let the mass of, because we have to calculate the percentage of free SO3 in the sample, right? So let the mass of SO3 in the given sample, in the given sample. So let's calculate the mass of the SO3 in the given sample of oleum. Right, तो इसको assume कर लेते हैं. So oleum is nothing but X. Okay. Now, what is the mass of H2SO4 in the given sample? Because oleum consists of only two things, that is SO3 and H2SO4. So if the mass of SO3 X, then definitely mass of H2SO4, right? Then the mass of H2SO4 definitely going to be, yes, that is 0.5 minus x, right? ये सबको समझ आया? Because the total mass is 0.5 and the total mass consists of only two things, that is SO3 and H2SO4. So that the mass of the SO3 will be x, then the mass of H2SO4 is nothing but 0.5 minus x. Now, how will you calculate the equivalent mass of each, right? So equivalent mass of SO3. We know how to calculate equivalent mass. Yes, that is the molecular mass, which is nothing but 80 in case of SO3 and divided by their n factor, which is equal to 2. So this comes out to be 40, right? So this comes out to be 40. Similarly, if you want to, calculate the equivalent weight of the anything like NaOH or MgOH2. So you always divide Mg in case of MgOH2, you take N is equal to 2. So these thing we already know, right? So equivalent mass of SO3 is nothing but 80 divided by 2, that is 40. Now you have to calculate the number of gram equivalent, right? So number of gram equivalent of SO3. So this is equal to, we know that mass is X and this is the equivalent mass, that is 40. So this is equal to x upon 40. Remember this thing. Okay, so far we calculate the number of gram equivalent weight of SO3, just like the normality. In case of normality, we are calculating the mass upon molecular mass. Instead of molecular mass, we are using here gram equivalent weight, right? That is molecular mass upon basicity or acidity, or in case of reduction oxidation n factor, right? So this we already calculate. Now let's see the next thing. Let's see the reaction part. Okay, so let's see the reaction part in the next page. That is what happen when the NaOH, right, is react with SO3. So we all know that when the NaOH react with SO3, the formation of Na2SO4 plus water will take place. Quickly balance this equation. So this is 2NaOH. Now this equation is perfectly balanced, right? So we know that 2NaOH react with SO3 to form Na2SO4 plus H2. Similarly, when the 2NaOH is react with H2SO4, H2SO4, then they will form Na2SO4 plus again 2H2. ठीक है. Now, so on the similar basis, just like a equivalent mass of SO3, you can also calculate the equivalent mass of H2SO4. So the value comes out to be, बेटा कौन बताएगा जल्दी बताओ. Equivalent mass of H2SO4, that is nothing but their molecular mass upon their basicity, that is 2, right? So this comes out to be 49. We all know this thing. And now similar way, the number of gram equivalent weight. Okay, so number of gram equivalent weight of H2SO4, that is the mass that we assume to be 0.5 minus x upon its equivalent mass, that is 49. So this is how we calculate this, right? Now we know that 20, according to the question, in this question it is given 26.7 ml of 0.4 normality NaOH. So this solution is completely neutralized, right? So we know that 26.7 ml, right, ml of 0.4 normality NaOH contain number of equivalent, hmm, equivalent of NaOH. This is correct according to the question. That is 26.7 ml of 0.4 normality NaOH consists number of equivalent of NaOH is nothing but equal to 0.4, and for the one we divided by 1000 and multiply by 26.7, right? So this is how we calculate, that is the amount of equivalent of NaOH by the 26.7 ml of 0.4 normality NaOH. Now, very important point, at equivalence point, right? At equivalence point. Okay. So at equivalence point, what is the number of gram, right? That is the number of gram equivalent, number of gram equivalent of NaOH, that is nothing but first one is x by 40 and next one is a 0.5 minus x divided by 49. So just solve this. So we already calculated this value. This comes out to be 0.4 divided by 1000 into 26.7, and from here we calculate this we take the LCM and calculate it like this will be 40 into 49. This will become 49x, and this will become 40 multiplied by 0.5 minus x. Right? So this is how. So from this equation, can you calculate x? Yes, because there is only one variable, na, x. Rest all are constant. So you can easily calculate x from this value, right? So on calculating x, what you get? So x comes out to be 0.1036, right? So this is the value of x on just solving this equation, right? So you'll get x is equal to this. Now, in this question, what they ask, you have to calculate, hence, percentage of free SO3 is nothing but is equal to 0.1036 divided by 0.5 into 100. right? So you'll get that is 20 point something, right? So we have option na, yeah, 20.6, right? So you get the answer like 20.69. So these are closely uh, numerically equal, right? So option C is the correct answer for this. So this is a very good question, good level of question, I guess, right? Which requires some very good concept so that only you can able to solve this question. Hmm? So this is the solution of this question, that is 20.69. Now, the second question, this question is also very, very, very important. And the question is, M2 ion is an isoelectronic of SO2 and has a Z plus 2 neutron, where the Z is the atomic number of M. Thus, what is the ionic mass of M2 plus? Right. So, according to the question, it is given that M2 plus ion, right? That is M2 plus ion is isoelectronic, is isoelectronic with, किसके साथ isoelectronic है, with SO2. So M plus 2 ion is an isoelectronic with the SO2. What does it mean, right? So M2 plus, because isoelectronic means what, contains same number of electrons. So they contain same number of electrons, so their value of electrons is same. Now number of electron and number of proton in M. So number of electrons and number of proton. So number of electrons and number of protons in M is. So in case of M, what is the number of electron and number of proton? So number of electron and number of proton is nothing but that is equal to 32 plus 2. Right, that is equal to 32 plus 2. How will you say that this is 32 beta? Because M plus 2 ion is an isoelectronic with SO2. And we know that in SO2, we know sulfur having 16 and O2 having 16. So they having 32, right? So they having 32 electrons and 32 protons in a neutral state. So we can say that if the M plus 2 ion is an isoelectronic with SO2, then it must have also same number of electrons. So they having the 32, right? So they having the number of electron 32, or we say the number of electron and the number of proton in M is equal to 32 plus 2, that is 34, right? So this is the value of Z. This is the value of Z. Why 2? Because plus 2 ion means already दो इलेक्ट्रॉन कम है, दो इलेक्ट्रॉन कम है मतलब प्रोटॉन तो ज्यादा ही होगा ना. So this is equal to 34. So Z is equal to 34. Now if you get the Z is equal to 34, now what is the number of neutrons? Number of neutrons. So we know that how will you calculate number of neutrons? Number of neutrons is nothing but number of neutrons is nothing but that is 34 plus 2, right? Because it is given that has a Z plus 2 neutron. So if Z is equal to 34 and plus 2, so that is 36. So number of neutron is 36. So neutron is 36, proton is 34. So in this question, what you want? The ionic mass of M2 plus is, right? So you calculate the molar mass, atomic mass. We know that atomic mass is nothing but the Z plus number of neutrons. So we know the value of Z, that is 34. We know the value of neutron, that is 36. This comes out to be 70 gram per mole. Hmm? So which one is the correct? That is option number A. So option A is absolutely correct for this, right? So this is the ionic mass of M2 plus ion. Chalo. Now, the next question is, each drop of H2O has a 0.18 ml at room temperature. Now you have to calculate the number of H2O molecule in one drop. So you have to calculate the number of H2 molecule in one drop, right? So let's see how will you calculate the each number of H2 molecule in the one drop, right? So here I am going to solve this question. देखते हैं फटाफट कि कैसे हम लोग इसको find out कर सकते हैं. So we all know that ना, what is the density of water? So density of water is equal to 1 gram per milliliter. Now volume is given. What is the volume? That is 0.0018, 0.0018 ml. Yeah, this is already given. That is 0.018. Okay, in this question only 0.018, sorry, right? So just wait. Hmm. So this is 0.18, right? So 0.18. So 0.018 ml is already given. So this is the volume. Now we know that if we know the volume and we know the density, then we can calculate mass or not. Obviously, we calculate. So mass comes out to be what? That is nothing but 1 into 0.018 ml, which is equal to again same 0.018 gram. Okay, so this is the mass. Now we know that number of moles in this gram of water. So mass is no. So how will you calculate mole beta? Mass upon molar mass. So we know this comes out to be 0.018 and the molecular mass of water is nothing but 18. Right, 18. So this comes out to be what? So this comes out to be 0.0, 0. Yes, you can solve now. This become 10 raised to the power 3. And this will become 18 we cancel 1 upon 10 to the power 3. So we can say that, yeah. So this will comes out to be 0.001. So this is the 0.001 mole. So this is the number of mole. Now we know that 1 mole of water by the mole concept, we know that 1 mole of water contain how much atom beta? Can anyone tell me? 1 mole contain how much molecules of water? That is 6.023 into 10 raised to the power 23 molecules. Right, in 1 mole, this molecule having. So in 1 mole having this, so in 0.001 mole. So in 0.001 mole, right? How many molecules? It is equal to 6.023 10 raised to the power 23 multiply by 0.001, or we say that it comes out to be 6.023 into 10 ki power 20. So this is the number of molecule in 0.01 mole. So this is also very simple question. So which one is the correct option? That is 10 raised to the power 20. That is B. So B is absolutely correct answer for this question. सो आई होप दिस इज ऑल्सो वेरी मच क्लियर कैसे किया हम लोगों ने कैसे सॉल्व इसको ठीक है चलो now one more important question is right so in this question what you need to calculate you just need to calculate the number of right mass of one atom of x is this gram then it is 32 gram is equal to so you have to calculate mass of one atom again this question is from the mole concept so we know that if the mass of one atom so mass of one atom is 2.66 into 10 raised to the power minus 23 gram then is 32 gram is equal to so mass of one atom so we know that that is the 1 mole is equal to what right so we all know that that is 1 mole is equal to nothing but this that is we all know 1 mole is equal to 6.023 into 10 ki power 23 in 1 mole atom having right hmm? Atom molecules or ion whatever and 1 mole is also equal to molecular mass so if the 32 gram is equal to 6.023 into 10 ki power 23 atoms. Right. So one atom having mass, one atom. So one atom having mass nothing but 32 divided by 6.023 into 10 ki power 23 atom. So this data is already given. That is mass of one atom. So mass of one atom is already given. That is this thing. Mass of one atom is already given then 32 gram is equal to. So what is the value 32 gram? So 32 gram is equal to how much they are asking. So if the mass of one atom is this, right? So if the mass of one atom is this, then it's 32 gram is equal to. So again this thing only, right? So it's 32 gram. So one atom का mass इतना है. तो 32 ग्राम का में कितने मास होंगे राइट सो यू हैव टू कैलकुलेट दैट 32 ग्राम इज इक्वल टू right? So 32 gram is equal to 6.023 into 10 to the power 23. So this having the one atom mass, right? So by this solving, you can easily solve this question, right? So just use this concept, you'll get the value like this. ठीक है, समझ आया सबको कैसे निकला? That is 32 ना, so you just multiply this thing by the 2.66 into 10 की power 23 grams, so you'll get the value. Okay, so option C is absolutely correct. Now, move to the question number fifth. That is what the question number fifth asks. Basically, a sample of CaCO3 is a 50% pure. On heating 1.12 liter of CO2 at STP is obtained residue left. So, a sample of CaCO3 which is 50% pure only. Now, on heating 1.12 liter of CO2 at STP is obtained. Now, you have to calculate this value, right? So, what is the value you need, right? Okay, so in this question, we are going to calculate the residue left, right? So I hope question number 4 is clear to all of you, right? Let me make a small correction. The question answer is this, right? Because you have to calculate the mass of one atom of X is this, then 32 gram is equal to. So 32 grams, so one atom ka mass agar itna hai, so then 32 gram is equal to, then divide the mass, whole mass, right? So then they are divided by the 2.66 10 raised to the power minus 23 because they are asking 32 gram. So which one is the correct option? That is option B, not A, C, right? Now let's move to the question number 5. So what the question number 5 state that basically a sample of CaCO3 is 50% pure. On heating 1.12 liter of CO2 at STP is obtained residue left, assuming non-volatile impurity is. So you have to calculate this. So now we know that number of moles of CO2 evolve, right? So number of moles of CO2 evolves is nothing but is equal to, they are already given all data, right? So this comes out 0.05. So this is the number of moles of CO2 evolve. Now we know that when we heat COCO3, what happen on why heat when we heating COCO3 beta? When we heat COCO3 on heating, right? So on heating CaCO3, it decomposes into CaO plus CO2. So their mole is given like 0.05 and again that is 0.05. So the CO2 is gas and they revolve out and the CaO is a solid which settled out, right? Now, so we can say that, so 0.05 moles of CaCO3 have have reacted, right? So we can say that 0.05 moles of CaCO3 have been reacted by looking at the equation. So what is the mass? So we know that mass is equal to nothing but 0.05 mole into molecular mass, that is 100. So this comes out to be 5 gram. 5 gram, or we say this is the 50% of calcium carbonate sample, right? So this is the 50% of calcium carbonate sample. Because calcium carbonate sample already in the question is given, it is 50% pure only. So 50% of calcium carbonate sample. So what is the total weight? Can anyone tell? What is the total weight? So the total weight is nothing but is equal to 2 into 5 gram, which is equal to 10 gram, right? So the total weight is equal to 10 gram. So what is the residue left? Can anyone tell? So the residue left by calcium carbonate. So the residue left by the calcium carbonate is nothing but is equal to 5 gram. Now the residue left by the CaO. So the residue left by CaO, right? So the residue left by the CaO is nothing but is equal to 56 into 0.05 or we say 2.8 gram. So can you tell me the total residue? One residue of 5 gram and another is a 2.8 gram. So total residue comes up 5 plus 2, 7.8 gram. So 7.8 gram is the correct answer, right? So total residue is 7.8 gram. So this is the residue left, that is 7.8 gram. I hope this is clear to you. चलो, now 100 ml of each 0.5 normality NaOH and N by 5 HCl and N by 10 H2SO4 are mixed together. The resulting solution will be. So you have to identify the resulting solution, whether the resulting solution is amphoteric or what, right? So try to solve this question. They are either acidic, neutral, alkaline, or what. So by considering the volume of HCl, we can actually come to the know that their value is what, right? They behave like a acid or base. Okay. So what happened basically? Basically, in this 10 ml of 0.5 normality NaOH, N by 5 HCl, N by 10 H2SO4 are mixed together. So we know that we know that, right? So whenever the 100 ml of 0.5 normality NaOH, so this is the 100 ml of 0.5 normality NaOH, N by 5 HCl and N by 10 H2SO4 mixed together. So resulting solution have an alkaline nature, right? So resulting solution become alkaline nature. Alkaline nature means we have like a basic nature, right? So this is what we have. Now, if you want to calculate this thing also, just wait for a minute. If you want to calculate and the exact thing, then you able to calculate this value by using the molarity or normality equation, right? So let's see the solution for the next question. Let's see the solution as well so that you better understand this question, right? So we know that according to the question, equivalent of acid. So equivalent of acid is equal to normality into volume, right? Normality into volume. So what is normality here? So normality is 1 by 5. Okay. So equivalent acid is normality 1 by 5. What is volume? So volume of the acid is 1 by 10. So this is 1 by 10. Hmm? So this is the normality, that is 1 by 5 1 by 10 into volume, that is 0.1. So on solving, this comes out to be 0.03. So this is an equivalent of acid. Similar way, equivalent of base. So equivalent of base. So equivalent of base. So the equivalent of base comes out to be 0.5. That is 0.5 into 0.1. So that comes out to be 0.05. So this is the equivalent of base. As the equivalent of base are more, right? As we can say that this is the equivalent of acid, this is equivalent of base. So as the equivalent of base are more as compared to equivalent of acid, so we can say that the solution is alkaline in nature, right? So I hope you understand. That is the equivalent of base is more as compared to the equivalent of acid. That's why the solution become alkaline in nature. Chalo. Now move to the next question. That is an element having atomic weight 75 and the B having atomic weight 25 combined to form a compound. The compound contains 75% by weight. Now the formula of the compound will be. So you have to identify the formula of the compound. कि क्या formula आने वाला है इस compound का. ठीक है. चलो. So 75% by weight का मतलब क्या है? ठीक है. 75% मीन्स 75% बाई वेट दे रखा है ना, तो इसका मतलब क्या होगा? दैट इज 75 ग्राम ऑफ ए इज प्रेजेंट. ए इज प्रेजेंट इन 100 ग्राम ऑफ कंपाउंड. ठीक है. So 75 gram of A is present in a 100 gram of compound. ठीक है. Now, so 75% atomic weight of A. So in this question, they said that the compound contains 75% A by weight. It means that 75% of A and rest is B. Now the atomic weight of 70 element A is also 75. So what is the number of mole comes out to be? So we can say that now, that is 75 is also equal to atomic weight of A. Atomic weight. So this is the atomic weight of A. So 75 divided by 75, so it comes out to be 1. ठीक है. तो ये तो 1 आ गया. Thus the atom of A in X is 1. So atoms of A in compound X is nothing but 1. Now, similarly, the second atomic weight is given, that is equal to 25. Again, this will be 25 upon 25. This again comes out to be 1. So the atom is present in the ratio AB, right? So they are present in the ratio A and B. So which one is the correct option? That is AB, that is D. So question number 8, D is the correct answer. Now, move to the next question. So according to this question, what they ask, the total molarity and the normality of all the ions present in the solution containing 0.1 molar of copper sulfate and zero point 0.1 molar of aluminum sulfate. So you have to calculate this, right? Total number of moles. So what is the total number of moles they are containing? So we know that the total number of moles in ions in the solution is zero point 0.1 mole of copper sulfate, which gives the mole of copper plus, that is zero point 0.1 mole, and SO4 plus, that is zero point 0.1 mole. So if I'm considering this copper sulfate, so when the copper sulfate dissociate into copper plus and SO4 twice negative, this will give zero point 0.1 mole of this and zero point 0.1 mole of this. ठीक है? तो दोनों का 0.1 0.1 मोल दिया. Similarly, when the Al2SO4 dissociate, so when the Al2SO4 dissociate into 2Al and SO4 twice negative. So again 0.1. So this will give 0.2 and this will give 0.1. Okay. So can you say what calculate the total number of moles? So total number of moles. So total number of moles comes out to be 0.1 plus 0.1 plus 0.2 plus 0.1. So it comes out to be 0.1, 0.3 plus 2, 0. Hmm? Okay, Al2SO4, the formula is incorrect because aluminum sulfate having, Al having valency 3 and 2. So Al2SO4 thrice, right? So here the value is 3. Al2SO4 thrice, 3. So this is 3 times of 0.1. So this will become into 3. So 3, point 0.3, 0.5, 0.6, 0.7. So total value comes out to be zero point 0.7, right? So this is the zero point 0.7 mole. So this is the total value of this. Now, total number of moles of iron we got. So by using this formula, total equivalent weight, we just calculate by using this formula because we get the total number of moles, right? Now, total number of moles is 0.7 mole. ठीक है, कितना आया टोटल नंबर ऑफ मोल? सो ये आ गया हम लोग का निकल के 0.7 मोल. सो आउट ऑफ दिस विच इन विच ऑप्शन 0.7 मोल इज गिवन? दैट इज option B. Okay, that is option B. So which one is the correct one? That is B. Similarly, you can calculate for the normality also. You'll get the value like 1.6. So this is what we have to calculate in this. I hope this is clear to you. सबको समझ आ गया होगा अच्छे से. चलो. Move to the next question. The percentage of P2O5 in diammonium hydrogen phosphate. So you have to calculate the percentage of this. ठीक है, कि कितना परसेंटेज निकल के आएगा इसका. किसका निकालना है परसेंटेज आपको? द परसेंटेज ऑफ P2O5 इन डाई अमोनियम हाइड्रोजन फॉस्फेट NH42. तो चलो देखते हैं फटाफट कैसे परसेंटेज निकालना है. So what is the percentage of P2O5 in the diammonium hydrogen phosphate NH4 twice HPF4? Okay. So we know that this quantity is a very simple question. Just multiply this 2 because I mean know the molecular mass of NH4 now. That is this NH4 become NH3 that is 34 and again 1. So this will become 36 plus 1 plus 31 plus 64. So this comes out to be 264. So total this is 264. Now, mass of P2O5. What is the mass of P2O5, beta? Can anyone tell? So, mass of P2O5 is nothing but 62 plus 18, right? This is the molecular mass, 16 5 the and 31 2s are 62. So, this comes out to be 142 gram. Just divide them. So, on dividing percent, you'll get the percentage. That is 142 divided by 264 into 100. So you'll get the percentage like 53.78%. So this is the value, right? So this is the concentration, this is the percentage of P2O5. So which option is correct? Option B. Sure. Now, the next question is question number 13. So let's see. Equal volume of 0.1 molar of AgNO3 and zero point 0.2 molar of NaCl are mixed. Now you have to find the concentration of nitrate ions in this mixture. ठीक है? तो चलो देखते हैं कितना मिक्सचर में होगा इसमें 13th क्वेश्चन में. So we know that when the equal volume of the two solution are mixed, volume get double and thus the concentration obviously change because the volume get double, then concentration obviously change because concentration is number of mole upon volume. So if the volume is, two solution volume, equal volume, and then they are added, they become double. The new concentration will be, so the new concentration will be what? That is M, and total volume is 2. So that is 0.1 divided by 2. That comes out to be 0.05 molar. So which one is correct? That is B. So this is absolutely correct. Now, let's see the next formula. That is 15. So I hope all of you do this question because this is very easy question and this is totally based upon the empirical and the molecular formula, right? So you can easily calculate this value. I accept all of from you that तुम सबने इसको अच्छे से निकाल लिया होगा because once you calculate the empirical formula na, we have to calculate the molecular formula. Then what is molecular formula? This is nothing but N into empirical formula. What is N? So we can calculate N by that is the molecular weight upon empirical formula weight. So this is X by 8 and divided by the empirical formula weight. And then just multiply by the empirical formula. So you get the value, right? So I hope all you calculate this value. This is a very, very simple question. Hmm? So I hope all of you easily calculate this. So the correct answer is C6H8N2. C6H8N2 C. So C comes out to be correct. To try to solve this, if you face any problem, then definitely we'll get into this. Chalo. So move to the next question. What the question asks basically, that is calculate the number of copper atoms in 0.3175 gram of copper. So you have to calculate the number of copper atom in 0.3175 gram of the copper, right? So we know that basically what is the molecular mass of copper? That is 63. So 63 gram contain 6.023 into 10 ki power 23 atoms of copper. Obvious. So we have to calculate for the 0.3175 gram. So this will contain 6.023, 10 raised to the power 23, and for 1 divided by 63 and just multiply by 0.3175. So you'll get the answer, right? So you get the answer like 3.035, 3.035, 10 raised to the power 21. So which option is correct, beta? 3.035, 10 raised to the power 21. So this is close to hmm, this one. Okay. So the value is very much close to this value, right? So try to solve this. This is a very, very easy. Okay. So the correct answer for this question is A, right? So that is 30.11, 10 is to the power 20. You just erase this, then you'll get the value like this. Hmm? Chalo. So next, move to the next question. That is question number 18. So an atom of the element X weight 6.644 into 10 raised to the power 23 gram. Calculate the number of gram atom in the 40 kg. Okay. So you have to calculate this in the 40 kg of it, right? So you have to calculate for the 40 kg of it. So an atom of the some element X weight this gram, right? So calculate the number of gram atom. So we know that atomic mass of an element, atomic mass of an element, atomic mass of element. So atomic mass of element is nothing but mass of one atom, hmm? Mass of one atom into 6.02 into 10 raised to the power 23. So what is this? This is mass of one atom that is equal to 6.644 10 raised to the power minus 23 multiply by 6.023 10 raised to the power 23. So this comes out to be 40 gram. This comes out to be 40 gram. Now, number of gram of atoms. So in this question, they're asking number of gram atoms. So number of gram atom is nothing but the mass upon number of gram. So mass comes out to be already given 40 kg, means 40,000 gram divided by 40. So 40 cancel. This comes out to be 1000. So what is the correct answer for this question? 1000. Very simple question, I guess. ठीक है, तो आसानी से कर लोगे ऐसे क्वेश्चन तो चलो. Now, in the second question, they are asking, calculate the volume of 20 gram of H2 at NTP. So this one is also very simple question. Just use the formula like PV is equal to nRT. We can use this formula to calculate the volume. That comes out to be nRT upon P. So what is N? Number of mole. So number of mole is nothing but mass upon molecular mass. So molecular mass of hydrogen is nothing but that is 2. And what is R beta? So R we know that is 0.0821. And what is T beta? That is 2 NTP. So 293. So at NTP, this is 293. Just divide by the pressure. The pressure we have 180. So just solving, you'll get the value, right? That is 20 by 2. That is, this will become 10. So just solve this, you get the value for this answer. ठीक है, so you get the value like 224 liter. So this is the correct way for solving. ठीक है, चलो. Move to the next question. That is the calculate the standard molar volume of the oxygen gas, and the density of O2 gas at NTP is already given. And you have to calculate the standard molar volume of the oxygen gas, and density of O2 gas is given. So let's see how will you calculate this thing. So this is also very simple thing. That is you have to calculate the standard molar volume oxygen gas. Density of O2 gas at NTP is already given. So this question is very important and also a very simple question, I guess, right? So let's see how will you solve this 21 question. So density of O2 is given, right? So density of O2 is given and it is equal to 1.429 gram per liter. So can you calculate the mole of O2? Hmm? So we can actually calculate because density is given. So by using a density, we can calculate the mass, right? So let's see the mass. So how will you calculate the mass, beta? Can you know? Yes, because this is O2 now. So O2 having molecular mass, that is 32 gram. So that is 32 gram per mole. So molecular mass of O2. Now, density, we all know that density is equal to mass upon volume. Hmm? And this value is already given, that is density is equal to 1.429. Mass is given, that is 32. So you can calculate volume, right? So from this, you can calculate volume. So volume comes out to be what the volume comes, that is 32 divided by 1.429. Okay. So this will comes out to be 22.4 liter of approx. So this will comes out to be 22.39 liter, or we can say that 22.4 liter, right? So this comes out to be 22.4 liter. So hence the standard molar volume of the gas O2 is 22.4 liter. So which 22.39 or 4, we can say that option D. So option D is absolutely correct. ठीक है, chalo. So let's move to the next question. The next question is what they are asking basically. So in this question, you need to calculate the value of this, right? That is the concentration of the sulfuric acid is better commercially is 95% H2SO4 by weight. So if the density of the commercial acid is this, then molarity of the solution is. So you have to calculate the molarity of the solution. So we know that 95% H2SO4 by weight. So we know what the meaning of this. That is the 95% H2SO4 by weight. So we know that 100 gram of H2SO4 solution, okay, contain 95 gram of H2SO4. This is the statement by the 95%. Now moles in 95 gram. So you can calculate moles in 95 gram is nothing but is equal to mass upon molar mass. So it comes out to be 0.96. Okay. So this is the moles. Now, volume of 100 gram of H2SO4. So, volume of 100 gram of H2SO4 is equal to, that is 100, and the density is given now, that is 1.834. This comes out to be 54.52. ठीक है, and centimeter, yeah, so 52.54. If you want to convert into the liter, then just multiply by 10 की power -2, then it become in liter. ठीक है, so ये liter में आ गया. This is the volume. Now, once you get the volume, now you can easily calculate the other values, right? So you get the volume. So what is the molarity? So you can calculate molarity, that is number of mole, that is 0.96 upon volume, that is 54.52 into 10 raised to the power -3. So it comes out to be 70 point something. So which one is the correct? That is A. So 17.8 is the correct answer. Okay, so let's move to the next question. That is question number 23. So what the question number 23 asks basically, what they ask generally, question number 23. So in question number 23, they are asking the ratio of the mass of oxygen and nitrogen in the particular gaseous mixture is 1:4. Now the ratio of the number of molecule. Okay. So we know that let the mass of the oxygen be W. Let us assume that. Let us assume that the mass of oxygen, the mass of oxygen, okay, the mass of oxygen be equal to W gram. So this is the mass of oxygen which is equal to W gram. Therefore, the mass of nitrogen. So what is the mass of nitrogen? So mass of nitrogen is equal to 4W gram because they are in the ratio 1:4. So let's calculate the moles. So moles of O2 is equal to weight upon 32. Similarly, moles of N2. So moles of N2 become 4W upon 28. Now, can you calculate the ratio of both this? That is NO2 upon NN2. So this comes out to be, can anyone tell? Yes, that is W upon 32 into 20 upon 4W. So W cancel this 4, 7. So that is equal to 7 by 32. So the correct option is D. So the option D is absolutely correct. Now, in the next question, you have to calculate the mass in gram of 0.5 mole of N2O4, right? 0.5 mole of N2O4. So you have to calculate the mass of this N2O4. So how will you calculate? Can anyone tell me? Can anyone suggest me? Calculate the mass in gram of 0.2 mole of N2O4. It's a very simple question. So I just hope that सबने सही किया होगा. Because mole we know, mole is equal to mass upon molar mass. So we know the mole, that is 0.520. We know the molecular mass of N2O4. So you can calculate mass easily. So you can calculate, right? So this is a very simple question. So I hope सबने ही कर लिया होगा, तो इसको सॉल्व करने की जरूरत भी नहीं है ना? ठीक है. सो चलो आगे चलते हैं. इसका करेक्ट आंसर सॉल्व कर लेना. 47.84 आएगा. ठीक है. Now, the next question is, that is the 1 liter of an aqueous solution of NaCl containing 117 gram of dissolved salt. Calculate the number of moles of solute in the solution. So you have to calculate the number of moles of solute in the solution. So 1 liter of aqueous solution of NaCl containing 117 gram of dissolved salt. Calculate the number of moles. So we can easily calculate. Now, this is also very simple question. Question number 25. So you have to calculate the number of moles. So what is number of moles? Mass, that is 117 divided by 58.5, that is molecular mass of NaCl. So this comes out to be 2 moles. So answer is 2 only. So this is very simple. Now, move to the question number 26. That is equal masses of H2O2 and methane have been taken in the container of volume V at the temperature 27. The ratio of the volume of the gas H2O2 and methane would be. So you have to calculate the ratio of these two. So let's calculate the number of moles of each. Then you can able to calculate this. So we know that, assume that 100 gram of each hydrogen, oxygen and the nitrogen are present, and volume of the gas is directly proportional to the number of moles of the gas, right? So the number of moles of hydrogen, oxygen, methane are Okay, can you calculate the molecular mass? We know that. So number of moles. How will you calculate the number of moles? So let's calculate the number of moles for hydrogen. So this is for number of moles 100 and the molecular mass is nothing but 2. Similarly for O2, this is 100 divided by 32. Okay, and for methane, that is 100 divided by 30. Sorry, methane na. So this is 16. 12 plus 4, 16. So the ratio of the volume of the hydrogen. So इनका ratio निकालें. So this ratio comes out to be 100 by 2, ratio 100 by 32, ratio 100 by 16. So this is 2. Hmm? So the ratio comes out to be 16, ratio 1, ratio 2. So this is the ratio, right? 16 ratio 1 ratio 2. So which option is correct? That is C. Now, move to the next question. That is, what volume of oxygen get O2 measure at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas, that is C3H8 measured under the same condition, right? So this is given 5 liter, 10 liter, 7 liter, 6 liter. So option are already given. So the correct option in the balance equation, basically what happened when the C3H8 is the react with oxygen. So this is the combustion reaction. So this will CO2 and H2O will be formed. Okay. Now this is their volume is 1 volume, 5 volume. This is 3 volume. This is 4 volume. Hmm? So this is all. Now, this value is already given 1 liter, 5 liter, 3 liter, and 4 liter. Okay. This is 2. Okay. Okay. Hence, the volume of oxygen gas measured at the 0 degree and the 1 atm I need to burn completely is 1 liter. So, the propane gas under the same condition is 5 liters. So, how much they will form? The propane gas under the same condition will form, that is 5 liter, right? So, they will form the 5 liter. So, the correct option is 5. Now, question number 28, that is 0.24 gram, right? So, the 0.24 gram of volatile gas upon vaporization gives 45 ml of vaporization and dp. What will be the vapor density of the substance? So, we know that vapor density is a very simple question. Vapor density is nothing but the molecular weight upon 2. This is a relation we all know. So, this is a molecular mass like 119 and 46, right? So, 119 and 46. And can you tell me this? This is 2. So this comes out to be 59.73. किसी को भी डाउट है कि ये 119.46 कैसे आया तो इसे देख लो. अब मुझे निकालना था मॉलिक्यूलर वेट. तो मॉलिक्यूलर वेट क्या था? 22,000 इंटू 0.24 अपॉन 45. सो यहाँ से मैंने मॉलिक्यूलर वेट निकाला जो कि निकल के आया. उसको वैल्यू को 190.46 उस वैल्यू को मैंने यहाँ पुट किया. So this comes out to be 59.7. So which one is correct? That is option. Now, the next question is that is the molecular weight of O2, SO2 are 32 and 64 respectively at 15 degree and 150 mm of Hg pressure. 1 liter of O2 contain n molecule. So you have to calculate the number of molecules in the 2 liter of SO2 under the same condition of temperature and pressure. Right. So we know that the temperature and pressure are already given and the volume is already given. So volume of SO2, right? So according to the Avogadro law, we know that according to the Avogadro law, right? So what Avogadro, that is volume is directly proportional to the number of moles. So we can say that V1 upon N1 is equal to V2 upon N2. Hmm? So V1 upon N1 is equal to V2 upon N2. So in this question, they are saying V1 is nothing but 1 and this is 2, this is N2. So what is N2? N2 comes out to be 2N. So which formula is correct? That is C. Okay? Chalo. So in question number 30, what they ask basically, what is the weight of oxygen required for the complete combustion of 2.8 gram of ethylene? So we have a ethylene like C2H4 and this undergo combustion reaction to form CO2 and H2. So this will form CO2 and H2. So we can say that 0.028 kilogram molecular mass है ना need they will need 3 into 0.032 is equal to 0.096 kilogram of oxygen. ठीक है. सो अगर 0.028 ग्राम किलोग्राम को 0.096 किलोग्राम ऑक्सीजन की रिक्वायरमेंट है तो 1 किलोग्राम को कितनी होगी भाई. तो 1 किलोग्राम को रिक्वायरमेंट होगी 0.096 डिवाइडेड बाई 0.028. ठीक है. दैट इज 3.42 किलोग्राम ऑफ O2. ठीक है. सो 2.86 को कितना चाहिए होगा. तो 3.42 into 2.86. So this comes out to be 9.7812. So this is the correct one. That is 9.712. So yeah, this is close to 6. So this is the correct answer for this question. Now, which one of the following have the maximum number of atoms? So you have to calculate the which of the following having the maximum number of atoms. So it's a very simple thing, right? That is the 18 ml of water, right? So 18 ml of water having the highest in this question. So before solving 34, let's see the solution for the 33 question. So 33 question is very much similar to the 34. So both are same. So I'm going to try going to solve one question and you just calculate using the same way. For example, 33, we know that 1 mole contain 6.023 10 raised to the power 23 atoms. And 1 mole also equal to molecular mass. So 1 gram of Ag. So in this 108 gram contain 6.023 10 raised to the power 23 atoms. ठीक है. In the second case 1 ग्राम ना तो 108 ग्राम इतना तो 1 ग्राम कितना करेगा 1 ग्राम इज इक्वल टू 6.023 divided by 108 raised to the power 23. We can also call it Avogadro number. So Na divided by 108. Similarly, in the second case, it will be like Na divided by 24, Na divided by 32, Na divided by 7. So ratio is in which comes 7. So this having the maximum number of atoms. That is which one. ठीक है. चलो. So in which of the same question, so they are also on the same basis. So 80 ml of water is the correct one. So try to solve this question. Now, if Avogadro number Na is changed from 0.062 to 0.6 to 10, this would change. So in the Avogadro number Na is changed from 0.623 to 0.610 per mole. This would change the mass of 1 mole of carbon from 12 gram to 12 milligram. Right, because 1 mole is based upon the take the definition of 1 mole from the 12 gram of carbon. So 12 gram changes 12 milligram. However, the following remain unchanged. That is the ratio remain unchanged. है ना? So what we can say that is the mass of 1 mole of carbon, right? So the mass of 1 mole of carbon. So this will going change. Rest all remains same. Now, the number of water molecules maximum. So this is also a very much similar type of question we already discussed. Okay. So this question we already discussed that the molecule of the number of water molecule is maximum in 1.8 gram of water or in this. So this is very simple. A mixture of gases contain H2 and O2 in the ratio 1/4. What is the molar ratio of the two gases? So this question already covered this because we know this thing. The molar ratio is already given, right? So molar ratio is already given. So by using the concept of this molar ratio, we can easily calculate this thing as well. So how will you calculate? Can anyone tell me? So a mixer contain H2 and O2 gases in the ratio 1/4. So let the if the mass of H2 and O2. So let's see if the mass of H2 is W. Hmm? Let me mass of H2 is W, then mass of O2 is 4W. So what is the molar ratio? So number of mole, that is mass upon molecular mass. So H2, we have molecular mass is 2. Similarly, for this, we use a mass. So mass is equal to 4W upon that is O2, that is 32. So what is the molar ratio? So if you divide this, what you will get? It is W by 2 divided by 32 and 4W. W get cancelled. 2, 16, that is 4. So this comes out to be 4 ratio 1, right? So this is the mole. So this mole comes out to be 4 ratio 1. So this is how we do get. I hope this is clear. कैसे आया सबको समझ? ठीक है. So option number D is absolutely correct. Now, the number of atom in 0.1 mole of triatomic gases. So this question is also very much similar. Just remember this. A molecule of triatomic gas is 3 atom. So given number of mole of gas 0.1, so mole of atom कितना हो जाएगा? In for the triatomic. So mole of triatomic. So triatomic means 3 atoms, है ना? 3 atoms होंगे. So just multiply 3 into 0.1. So कितना आ जाएगा? आपका 0.3 mole. Right? So we know that 1 mole contains 6.02, so 0.3 mole contain what? So 3 mole contain 3 into 3 into 0.1 into 6.023 into 10 के power 20. 18 लगभग कौन सा आएगा 1.86 10 की पावर 23. So this is how will you calculate this. ठीक है, समझ आ गया सबको? ठीक है. Yes, so B is the correct option. The maximum number of molecules. So this is also very much similar. We already discussed such type of question. So there is nothing new in this. So the number of atom in 4.2 NH3. So this is also very, very simple because we know that 1 mole of NH3, NH3 means 17 gram. So 17 gram contains 6.023 10 raised to the power 23 atoms. Okay. So 4.25 gram contain how much? So for 117 multiply by 4.25. So 4 4 4 and 6. So 6 and 4. 1 point something, right? So this will comes out to be this. So this one is very, very important question. So we already cover all this question, right? Which of the following fertilizer has the highest nitrogen percentage? That is urea. So this we already know. So this will contain the highest percentage. Yeah, the one which is very important. Yeah, that is question number 49. So this one is also important. So I am going to solve this as well. That is, you have to calculate the number of moles of hydrogen molecule required to produce 20 mole of ammonia through the Haber process. We know that what is Haber process? N2 plus 3H2, and this will gives us 2NH3. Right. So 20, now in the question, how many moles of hydrogen molecule required to produce 20 mole of ammonia? So you have to prepare 20 mole of ammonia, and it is given how many moles of hydrogen. So hydrogen is the limiting reagent. So we know that 3 mole of hydrogen produce 2 mole. So, है ना? So for 1 mole of ammonia, you need 3 by 2 mole of hydrogen. So 20 moles, so just multiply 20 to 10, 10 is a 30. So that is the 30 mole of hydrogen is required to produce 20 mole of ammonia. Right? So this is all about. Now, the next question is also very, very simple. That is, you have to calculate the molarity only, na? So molarity of the solution. So the correct answer for this answer is C, and it's a very simple. That is the density of 2 molar aqueous solution of NaOH is this. The molarity you have to calculate. So molarity, you know, and the no density also, you know. So just by density is equal to mass upon volume. Okay. So from this, you need to calculate the volume, which is equal to mass upon density. So total mass of the solution, that is a 2 molar aqueous solution, means 2 mole in 1000 ml, right? So total mass of the solution is 1000 ml. So just put the value and you can easily calculate this. So I hope this is very much clear. We already covered important question because this video is going to be too long. That's why I'm not going to discuss a simple question. I hope you all do this question in a good way. So we all cover all type of questions which are very important in a point of view. So I hope you get the clear idea about this question. That is what mistake you did or what you learned from this AIT first paper. So thank you very much. So let's meet in the next class where we'll discussing about more about the topic. Okay. So till just take care and try to revise and practice as much as you can.